So, welcome everybody to the Tidepool Education Training for 2026 for Stewards of the Coast and Redwoods. And this portion is going to be led by Hollis Bewley, our wonderful, incredible, experienced program coordinator for the Tidepool Education Program. Thank you, Hollis.
So, let me clean up my screen a little bit. Okay, can everybody see the first slide? It reads Tidepool Ed Program Logistics. Okay, thank you, Elise. I'm going to talk about there are three ways you can participate in the Tidepool programs. And I'm going to be talking about the Tidepool Ed program tonight and a little bit about our touch table, and then we're going to do something a little bit different with roving this year. So that's to be determined later. And so our Tidepool Ed program, we accompany groups of classes out to the tide pools. And the way it works is that we assemble a calendar. This is a schedule from a couple of years ago. And because of the way the tides work, they're concentrated every other week. We have a series of low tides, hopefully negative tides. And so they're all scheduled and compressed into this tight little schedule. And you can see during this 1 week, this is just Monday through Thursday, and we have 5 field trips that are scheduled. And we've even doubled up. On Thursday, we have 2 groups coming out. And we manage this. We like to go to Miwok Beach, which is north of North Salmon Creek, because it's a broad, flat beach that has good exposure of life on the rocks up to about a plus 1.7 tide. So that gives us a little bit more flexibility on the days that we're able to schedule. And we do have room for 2 classes if they're not too large, if we kind of stagger their arrival time. So this is what the schedule looks like. It's posted on the Google Drive. Every so often, I send out an SOS for requests for people to sign up. They get back to me, and we plug them into the schedule. So we have 4 tide pool packs that are kept in a locker. We have 1 locker at the Salmon Creek Ranger Station and another locker up at Jenner. And the packs contain some laminated emergency contact information, some talking points about tide pool etiquette and ocean safety, and this little front pocket down here. By the way, does my pointer show up on the screen? Because sometimes it does and sometimes it doesn't. It does? Okay, good. This little pocket down here, I like to point it out because people forget about it. It's filled with magnifiers. And once you get out there and you start examining some of these animals close up, you'll understand the value of having the magnification, because you're able to see a lot more, especially if you're looking at a little rock that you've pulled out of a pool that might be covered with tiny little spirobid worms and little bryozoan animals. And we have packets of rat cards on volunteer opportunities, our environmental education programs, maps, where can I take my dog? And if you're roving, you can kind of collect your own little packet of things that you like to share with park visitors that you talk to out there. And we have 3 field guides. The seashore of Northern and Central California is nice because it's very, very tough. The back cover has a color-coded index so that it makes it easy to find, okay, crabs are on pages 75 to 85, for example. Unfortunately, if you're interested in having this in your own library, it's been out of print for a couple of years, but used copies are available online. This little blue book down here is the Pacific Intertidal Life, and it is all black and white line drawings. However, it is amazingly comprehensive for our area, and it has really good information about the animals. This went out of print a few years ago, and we were scrambling to round up as many copies as we could. New copies now go for about, I think it's $6 or $7, but the used copies that we could find online when it was out of print were going for $75 and $85 a piece. So that's how valued this book, and actually all of Ron Russo's, the whole series, is. And this book, this quick field guide to tide pools, is a nice photographic field guide. It's not as comprehensive as either one of these, and it doesn't have quite as much information in terms of the text, but the photographs are really nice and it's really easy to locate items. Then we also have laminated field guides. One shows the different splash zones. Tidepool Bingo has animals on one side and algae on the back side. And these are arranged by the intertidal zonations, which I'll talk about in a minute. And then the Limpets program, it's a monitoring program that is managed by the Greater Farallones Association. And they put together this wonderful large size photographic field guide, which they've given us permission to print and laminate and use for our field trips as well. So we come up with a pack strategy. There's no point in picking up the packs and one, on a Monday morning and then returning them all Monday after the field trips, and then somebody else has to pick them up for the Tuesday's field trip and then they're returned. So if we have somebody that's coming out 2 days in a row, they can take the packs home with them and bring them back the second day. And we meet in the parking lot generally about 20 minutes before the buses are expected to arrive. And these vests are also contained in the packs. And so we wear identifying vests. We distribute field guides. People have their own or their favorites, and then sometimes they have their own. And we kind of set up a strategy for the day. So they usually arrive by bus. Sometimes the smaller groups arrive by car. Occasionally, we will do a talk. We will talk to them while they're still on the bus and they're contained about ocean safety rules and also tide pool etiquette. But we often just do it on the beach before going down the trail to the sand. Now, we have talking points, and I send them out to the teacher a week before the field trip when we contact them to confirm. And I request that they go over them with the students in the classroom before they come out, because the kids are generally a little bit more attentive when they're in the classroom than when they're standing up in the parking lot, anxious to get down to the beach. I do want to mention that because of a grant program, we are able to provide transportation scholarships to Title I schools who have not been able to afford the transportation costs to bring their kids out on field trips in prior years, in the past. And this has been wonderful. It is just amazing how many kids live in Santa Rosa and go to school in Santa Rosa and have never seen the ocean. So what you're doing, if you accompany them on a field trip, you are sharing their very first ocean experience. And it's just really an amazing feeling. I have been out there. I've been out on the beach on Monday afternoons that are school holidays, legal holidays, and run into parents and their kids out there. And it turns out that the kids had come out for a field trip and then they bring their parents out, which is, we know that we've done the right thing. So we talked to them about being safe. And some of the ocean safety talking points are to note the safety warnings on signs. Never turn your back on the ocean. The algae covered rocks are slippery. We want to make sure that they're all wearing protective shoes, no bare feet. We talk about a 3-point stance for balance, and it's really good if you have access to walking sticks. It kind of helps you balance yourself when you're out navigating the rocks. And we ask the kids to stay with a partner, not go off by themselves. And when we get down there, we ask them to leave their backpacks and lunches above the high tide line. The tide's usually coming in while we're down there. And then we talk about some tide pool etiquette. We ask them to try to step on bare solid rocks because animals hide under the algae and live under loose stones. And there's no pulling animals off of the rocks. Some of these animals have blue blood. They have no coagulating agent in their blood, so they can bleed to death internally if they are yanked off of the rocks. They use strong suction in order to secure themselves there so that they can withstand the surge of the waves. We handle animals with wet hands. A lot of programs are no touch. We don't do that. We do bring some plastic containers with us. And one of the problems that these animals have during a low tide when they're exposed to the dry, warm air is desiccation. And so we don't want to create more of a problem by handling them with dry hands where we're absorbing moisture out of their bodies. So we're always keeping our hands wet in the seawater. And we return animals exactly to where we found it. They have very small areas that where they're able to survive, both in terms of how often that area is covered with water and how often it's dry, and then also the neighborhood. One other problem that they have when the tide goes out is exposure to predators, and it is a dog-eat-dog world out there. So we always return an animal to exactly where we found it because they've established themselves in that little neighborhood. And if you lift a rock from a tide pool and you look underneath, you find all kinds of fascinating colonies of little animals, but we want to replace it exactly as we found it. So those that are living on top of the rock are there because that's where they can survive. Those that are living on the bottom of the rock, it's because that's an optimal place for them, but we want to gently replace it so that we're not crushing anything and so that they're oriented properly. And of course, there's no collection of live or dead animals. The shells are valued homes for hermit crabs, and the dead animal bodies themselves are food for others. So if we go to Miwok, we generally park at the North Salmon Creek parking lot. And one nice advantage to this, but we're not taking full advantage of it, unfortunately, is that there are three ecosystems that we're exposed to. There's the creek itself, and there's the sandy beach, and then we walk down to Miwok, where the rocky intertidal is. We don't do sandy beach interpretation except on a rare occasion when the teacher and the class has an interest in doing something after their tide pool exploration. And it's not that the sand is bereft of life. It is filled with life. It's just that it's not quite as obvious and there isn't quite as much of it. But it's something that I'm really interested in getting into at some point. So we get down to the beach, and as I said, we want to park all of our packs and lunches and all of our gear somewhere up above the high tide line. You can see the wet sand here where it ends, and presumably that's the high tide line. And so the kids parking their stuff on the rocks. And the first thing that I do is I'm looking for a rock that looks like this. And can anybody tell me if what's going on this rock? Well, it's covered with animals.
Yeah,
It's
love those.
yeah, it's covered with aggregating anemones, and these are clonal colonies. You see the seam down here that separates these two groups. This is one clonal family on one side of the seam, and another clonal family on the other side of the seam. And these are cnidarians, and cnidarians are characterized by stinging cells. And the anemones, they're wide open when the tide is in and they're underwater so that they can capture their prey. And they have kind of sticky tentacles. And so what they're doing is grabbing little pieces of sand that's in the surf, and they're covering themselves with the sand. And so when the tide goes out, they close up. And the sand protects them from the sun and protects them from drying out, but it also kind of camouflages them. And so the kids don't recognize them as animals, and they're likely to just be climbing all over them. So we like to point it out to them. And I generally ask them to touch them really carefully and really softly there so that they can feel the moisture. The interesting thing about these animals is that they can reproduce sexually, but basically they reproduce by cloning. And so we have one family on this side of the rock, another family on this side of the rock. And when the tide comes in and they're covered with water, they actually send little scouts out into the middle of this demilitarized zone here. And they actually fight each other to maintain their territory and that seam. And in the folder of handouts, there is a document that is the secret lives of the animals that we see out there and what they're doing when we're not looking. And there's actually a video of a fight going on between two of the anemones. Now, this is how they clone. This is one animal here, and what it's done is it's actually started to walk. Um, it's pulling itself apart, and it's walking on both sides, and it keeps pulling, and then it kind of snaps in the middle and becomes two genetically identical animals. And so when you see a group like this is an entire clonal family here that has divided in the way that this one did here. Here's another seam, and this is tar spot algae that is growing in between. Tar spot algae is very, very slow growing. So that kind of tells you that they have maintained this seam. They've been battling over this territory, but maintained this division between them for quite some time. Okay, this is a still of two of the aggregating anemones fighting. And these green tentacles here are filled with nematocysts or stinging cells. And what those blue tentacles do is that when they're underwater and little fish and little food bits are going by, the tentacles are kind of sticky and they will shoot. It's almost like a little missile strike of a substance which paralyzes them. And then they fold them over and they bring them into the oral disc, the central disc, which is a mouthful. Actually, it's both an in and out hole. That hole does everything. It's for both expelling waste, bringing in food, and actually, with some species, babies are born actually through that oral disc. So this is the purpose of the green and blue tentacles. But when they rear up, they have this set of white tentacles underneath. And you can see that some of them are torn. And the reason they're torn is because they have fired stinging cells at each other in this case. And they will battle. They could kill each other, but they will battle until one backs off. In the case of those clonal families that we saw, till they back off and maintain that space. So the anemones are they're of the cnidarian family. If you take an anemone and you turn it upside down, you have a jellyfish. There are other animals that are hydroids that grow on stalks. And those are colonies of, again, they all have stinging cells. They all have this radial symmetry. And this is some of the containers. This is a couple of the containers that we bring out with us. And when we do put animals in containers, we're very cautious about leaving them in the sunlight because the water heats up quite quickly. There's one class that comes out every year, and it's a 7th grade life science class. Well, actually, it's 5 periods of classes, and they bring their quadrants, and they have an assignment that we help them complete. And we start off in the low tide zone, and with the quadrant, they'll document the different families of animals that we find there, if it's cnidarians, if it's an anemone, or if it's mussels, or it's sea stars, and they'll do a count, and then they'll sketch in the algae. And when I talk about the low tide zone and the mid tide zone and the high tide zone, I'm talking about a vertical separation of different kinds of animals that are separated by their tolerance to the warm, dry air and low tide. And this is analogous to, there are different plants that live at different elevations on a mountaintop, for example, because some of them can tolerate the colder, drier, higher elevations than others. On this rock here, you can see this band of black mussels. And they stop right about here. And below, you can see anemones. And what's happening here is that these mussels are indicative of the mid-tide zone. And they would actually prefer to live farther down the rock because they're covered by water for a longer period of time, meaning that they have greater feeding opportunities. They're filter feeders. They have greater feeding opportunities, and they're not exposed to the warm, dry air for as long. They're much more comfortable living down in this lower area here. But one of the primary predators of the mussel is the pisaster, is an ochre sea star who prefers the low tide zone here. And so the sea stars keep the lower reaches of the rocks free of mussels, enabling anemones and other animals to occupy those lower reaches. Sometimes they'll go out to Campbell Cove, where Karen was, which is it's at the mouth of the harbor of Bodega Harbor. The nice thing about this with the younger kids is that we don't have to worry about waves washing anybody away. It's nice, calm water. And the animals are a little different here because they're not exposed to the wave action that they are out on the outer coast. And Sarah here is holding one of the stars of this area. This is a big Lewis moon snail. And it has this wonderful circular shell and this huge foot that hangs out here. And right now it's inflated with water. And so if you touch it, it will shed the water so that it can withdraw back into its shell. And this is a mollusk. This is one of the member of the mollusk family. And mollusks are soft-bodied. Most of them have a muscular foot for locomotion. They have a visceral mass which contains their internal organs. It doesn't look like much, but they actually do have internal organs in this shell. They have a mantle. Most of them have a mantle which will secrete a carbonate shell, but not all. And they usually have bilateral symmetry in that you can divide an animal in half and their left side would be a reflection of the right side. And all mollusks, well, most of them, have a radula for feeding. And a radula is a specialized organ, which is, it's like a tongue, and it's used for processing food. Now, some of these animals are vegetarians, and they'll scrape algae off of rocks, and their radula, their tongue is sort of like a file that they can use for scraping. Others, which are carnivorous, like this one, their radulas are actually a drill. And somebody has a raised hand. Does somebody have a question?
Yeah, I do. How old is a snail that size?
Good question. I don't know.
It looks so big. I thought,
But,
boy, it's gonna be
yeah,
a little-
I know. That's a great question. And I really don't know. Does anybody else know? That's on here. They start off, like this size. And then, gosh, I really don't know. And now I'm dying to find out. Thank you for that. It takes a while, though. And by the way, if anybody has questions, just jump in. Okay, so the radula that this animal has, it functions as a drill. And so one of its favorite food is a cockle or the clam shells. And because this faces the harbor and it faces the bay waters, the area is loaded with different kinds of clams and different kind of cockles that aren't found on the open ocean side. Because they can't, they bury themselves in the soft, silty sand, and they can't exist out there with all of the heavy surf and all of the wave action and all of the rocks. They would just be thrown apart and broken up. But what the moon snail does is it will chase a clam or a cockle in the sand, and there's a video of it in that document with its big foot, and it'll hold it down. And then it takes this radula and it will drill a hole into the umba section, the base of the shell here, and then it secretes an acidic substance which kind of dissolves and melts the body, and then it sucks it dry. So when you're out at Campbell Cove, often you'll find these clam shells that look like they're intact and they look like they're whole. But if they have this characteristic countersunk hole in the umba, you know that it's been eaten by a moon snail. Another indicator of the moon snail's presence is this egg casing. And it looks kind of like a toilet plunger, but really it is a combination of mucus and sand and eggs. And they're often kind of half buried in the eelgrass there. Again, this is out at Campbell Cove, and what this class has seen is some raccoon tracks. And so they recognized it as a raccoon because they have a garden at their school and they have some little track things. But here they were actually able to follow the tracks down the beach to a hole where the raccoon had dug up a clam. And then you could see the raccoon took the clam down to the water and washed it off before eating it. And so even though we're out there to get out to the jetty and to look at the animals that are on the rocks and hidden in the algae, we do pay attention to the other things going on. And on this very same day, actually, I glanced up and there was a bobcat that was walking along the rocks on the edge here, and then he disappeared into the hillside. So we don't want to lose these opportunities at all. This is another mollusk, and this is a mollusk that does not grow a shell, but it is extremely intelligent, and we often see them at Campbell Cove. Sometimes they are stranded
I see them at
up
Campbell
on the
Cove
rocks when the tide goes out.
when the tide goes out.
Yeah, so
Really?
this is a red octopus, and they get to be maybe about this big as adults. And inside its mantle has a liver. It has a pair of kidneys. So it has some of the same organs we have. It has 3 hearts. And the reason why is that one of the hearts is for circulating its blood. It has very, very low blood pressure. I believe it was measured at something like 45/15. And so, they're capable. A pair of hearts, which are situated next to the gills, which are almost like turbochargers for bringing in oxygen and giving them the energy so that they can zoom themselves off. I'm getting a message that my internet connection is unstable, so I'm hoping that I don't get lost here. As well as the selection of organs, it has this incredible brain, which extends down into each of its 8 arms, which can operate kind of independently. So it's actually an animal with 3 hearts and 9 brains, and it's very, very intelligent. This is a baby, and you can tell that it is completely relaxed. It is not changing color. Its skin is really smooth. There's no white bumps on it. And when my husband was holding it and I was walking around photographing it for quite some time, it was following me with its eyes, just like I was. It was as interested in me as I was in it. It was very, very curious, very, very relaxed. This is a mollusk, and this is called a nudibranch. And again, this is a mollusk without a shell. But it has all of the other characteristics, including a radula and including the soft body and the muscular foot for locomotion. And they come in a couple of different body plans, and this is the aelid plan. And it has this soft body. These 2 appendages up here are for the rhinophores and their sensory organs, and they kind of They almost like smell chemicals in the water so that they can track down their prey. And these wonderful orange-tipped finger-like projections here are serrata, and they serve multi-purposes. They're the gills, actually, and they also hold the digestive system. And this particular species, the Hermescenda, the opalescent nudibranch, feeds on cnidarians. And remember, cnidarians have the stinging cells. And these nudibranchs have a mucus which renders them impervious to the stinging cells of their prey. And they can absorb the stinging cells into their digestive tract and hold them in the serrata and then use them for their own defense. So they're not born with these harpoon-like defensive mechanisms, but they absorb them from their prey and then are able to use them for themselves. And this is how they get away with these bright colors. It's the same way that a butterfly gets away with bright colors, in that it's a warning to other animals, don't eat me, I will hurt you. This is the same body plan. It's the aolid body plan, but this is a shag rug. And again, there are all these serrata here, which work as their gills and their digestive tract. And here are the little rhinophores here. And these come in different colors. And the coloration, not only do they absorb the stinging cells from their prey, but they can absorb the color too. The first I saw pink one was out at Campbell Cove, and I didn't even recognize it as a shag rug nudibranch at first because I had never seen a pink one, and I always seen in shades of white or tan or a light brown. And then about 6 inches away, I saw a pink anemone, and it almost matched it. Then I realized, oh, okay, it's a shag rug, and what it had done is it had absorbed the pink coloration from its prey. This is another nudibranch, and this is a dorid body plan. And so it has a flat body, has these little tubercles here, and this little flowery ring down here are its gills. And Gary, did you have a question?
Yes, this is really fascinating. I was wondering if you could give us an idea of the scale of these little creatures that we're looking at.
Oh, this is a macro lens. Okay, and so most of these animals are maybe a couple of inches long. So we're looking at a close-up magnified view. There is one visitor that we get very occasionally, and it is called a sea hare, and it's of the same family, but it can be like maybe 18 inches long. But that is rare. We only get them with a flush of warm water. So these guys are maybe, a couple of inches long. Some of them are really, really tiny. These are the rhinophores here. One way you can get an idea of the scale is that it looks like it's on pebbles. These aren't pebbles, these are grains of sand. This is fine sand. So these are all taken with a macro lens with my camera. This is another dorid. And again, it has this ring of gills on the backside here. And then this is a sea clown, and it looks entirely different from the others. We have a group of docents that we refer to ourselves as the nudie nerds, and have fallen in love with nudibranchs. And it's always really a thrill to find one of these treasures. This is a ochre sea star, and it's an echinoderm, and the echinoderms have spiny skin, and that's their primary characteristic. And you can see all the little spines all over his body here. And I was talking before about the vertical zonation and how the mussels are indicators of the mid-tide zone, although they would rather live in the lower reaches. And this is the reason why they can't, is because these guys patrol the low tide zone, and the mussels are a favored prey. And all of the sea stars have a little intake valve on their body. It's a madrepite. And what it does is it absorbs seawater into the body, and there's a series of canals inside. And what happens is that they use hydraulics with the water in order to control their tube feet. And here's a drawing showing how it works. These animals have radial symmetry, but interestingly enough, as larvae, they are bilateral. And there's been quite a bit written about the advantages of being bilateral and having a head. And so it is thought to be a more advanced body plan than these that are round, symmetrically round. However, interestingly enough, these animals start off as bilateral, and when they reach an adult stage, they have converted into a radially symmetrical animal. Until recently, it was thought that they had lost their head during this metamorphosis. And there are recent studies on the types of cells that are found throughout all of their arms indicates that they're really closer genetically, they're much closer to cells that you would find in a head than in the trunk. And so they look like they're just arms, but they're actually all head. This is a fascinating thing about all of these invertebrates is that the people that study them are learning more every day. I was talking about the tube feet, and here you can see the tube feet coming out of the bottom of the body here. It's for locomotion. They're used for gripping themselves onto a rock so they can withstand the surge of the wave. But this one has caught himself a clam. And what he's doing is he is pulling on the clam shells. The clam is using a muscular motion in order to keep those shells closed. But the sea star has this hydraulic system, the water running through those canals, so that they don't get exhausted, they don't get tired. And so they can outlast the muscles of the clam. And all it requires is just a few millimeters opening. And then the sea star ejects its stomach, inserts it into the shell, and digests the meat while this animal is alive. And the document that I sent out on the secret lives of these animals, there's a link to a video that was taken with a camera that was inside a mussel shell that shows the shells being pried open and a sea star stomach coming into the shell to digest the meat. With this one has gotten the clam open here. They don't look like heavy-duty predators when you see them on a rock, but they really are. And in fact, they're a keystone species out there because what they do is they determine the level of biodiversity that's able to exist on that rock. About 10 years ago, when we had the warm water blob, we had the sea star wasting syndrome, and it affected about 20 species of sea stars, including this disaster. And when they disappeared, all of a sudden the mussel beds went all the way down to the sand level without the sea stars there in order to keep the base of the rocks clean. And what that did was it limited the biodiversity living on that rock because the mussel beds just took over. These animals that have repopulated are actually mutants. There's a mutant gene that enables them to better tolerate the warmer water, and their immune systems are less stressed, and they've repopulated themselves here. But it's an adaptation that they've made genetically. We've actually been watching a kind of evolution in real time over the last 10 years as they've made a comeback. The fantastic sunflower stars, which are a couple of feet in diameter and they can have 20 to 25 arms. We used to see 5 or 6 of those on every field trip. We took them for granted. They have not recovered on their own. There are labs that are growing them now. and they were in the giant kelp forests. And what happened when we lost these wonderful sunflower stars, the purple urchins took over, and they can mow down a kelp forest very, very quickly. And so we've lost our kelp forests up along the Northern California coast. And the kelp forests are really important little ecosystems of their own because they are good for juvenile fish and they support their own little communities. And so there are a lot of efforts being made by a lot of different laboratories and a lot of different people to try to restore them. This is part of an everted stomach. It's coming out of the central core of a pisaster, an ochre sea star. With the sunflower stars, I've seen stomachs that are like this big coming out of these giant animals. And I was talking about how the cells throughout their body genetically are more similar to those that you would find in an animal's head rather than the trunk. And this is a wonderful photograph that was taken at Stanford University of the nerve ring of a young sea star. And it's quite beautiful, but it also shows how sophisticated it really is. This is a bat star, and they are, for the most part, they're vegetarians. They'll eat algae, but they'll also, they're opportunistic. They will also eat meat on occasion. And it has madrepite right here. It operates the same way. It brings in seawater with the canal system. And the echinoderm, I say that it's, they're spiny skinned. One reason that it's really nice to have the magnifiers out there. This animal, by the way, is about this big. It's about this big around. Comes in different colors. But again, this is a close-up photograph. And this is even closer so that you can see that he's covered with all of these spines. They also have other little finger-like organs all over their bodies, which are constantly picking off algae and dirt. And that's why when you see them, they always look so clean. This is a bright red one that I had in a tray, and I turned my back and he was escaping, but I just love the way he was hanging there. Sometimes with the bat stars, if you look at the underside, there's a groove that goes down the center of each arm. That's where the little tube feet come out. And if you just kind of gently spread them apart, you'll see a little worm living in there. And it is a symbiotic relationship. The worm is taking advantage of any scraps that are left over by the sea star. And he's also kind of keeping that groove clean for the star. This is another echinoderm. And if you were to take a sea star with the 5-point symmetry, and if you were to curve it like this, you would wind up with a sea urchin. This is the bottom side of the sea urchin. This is a purple urchin, but they begin life when they're very small, they're green. And this one is, I'm assuming he's kind of an adolescent because he's turning purple. And this is his mouth. You can see little tube feet here, just like in the sea stars. And the spines are much more exaggerated and prominent than on a sea star. And the oral cavity here is called Aristotle's lantern, and I would love to know why. I've never been able to discover the reason for that. But you can see that it has 5 teeth. So that radial symmetry, 5-part symmetry, goes right down to the mouth. And I have seen films of them munching on a piece of kelp, and it's just fascinating to see those 5 teeth chewing simultaneously like this. This is an animal that this is an animal colony actually, and this took advantage of the lack of sea stars during the wasting syndrome. These are sandcastle worms, and before the warm water blob in 2014, 2015, there were several reefs of them on Pinnacle Gulch Beach, which faces Bodega Bay. And on the outer shores, there was one section of them on a rock on Marshall Gulch Beach, going up towards Carmet. And that was the only section of sandcastle worms that I was aware of on the outer coast at that time, on the beaches that I'd been tide pooling at. And what happened when the ochre stars disappeared, it enabled some of these sandcastle worms to colonize there. And they build these colonies out of grains of sand. This is a macro, it's not a macro photograph, it's taken with extension tubes. So Gary, you're talking about scale. This animal is maybe 1/4 of an inch when it's extending from its tube. And again, its tube is made up of tiny grains of sand. It has these tentacles. And so the waves come in and the tentacles are grabbing food, but they're also grabbing little grains of sand and moving them around and feeling them, rejecting them, grabbing others. And then it exudes a glue, a cement, and it cements its tube. It creates its tube. And this glue, I mean, these little grains of sand, they withstand, you can walk on a reef of them. They'll hold up your weight. McClure's Beach and Point Reyes is just loaded with them. You can walk right out on them. They're that strong. They withstand the wave action, the surge of the waves. And so chemists have been trying to replicate it for use, for medical uses, for mending bones, dentistry. There are all kinds of potential uses for a substance that's that strong. And this is a little baby elephant seal that joined us one time. It's not an invertebrate, but I had to include him because you never know what you're going to see out there. So this is our touch table, and it was built for us by somebody at the Bodega Marine Lab. And different events. We have the North Bay Science Discovery Day, excuse me, coming up at in, is it March? I'm not sure, it's on the calendar, but it's an annual event at the fairgrounds. It also goes to Fish Fest, and occasionally it'll go to events at schools. And one of our docents goes out to the Marine Lab in the morning and will pick up some algae and seaweed and different animals, and also the seawater. And we have a pump and a cooler, and it gives the kids and their families an opportunity to examine some of these animals close up. And we don't need a low tide, and we're not dependent upon the beach. And so it's kind of like a mobile intertidal zone, and it's a lot of fun. As I said, we're going to talk about roving docents at a later time because that's kind of in transition. So that's a group of docents after a field trip. So I'd like to introduce Judy. Judy is a dedicated Tidepool docent, and she just loves what she's doing, and I asked her if she would share her enthusiasm. So Judy, if I'll drive if you just tell me when to change.
All right. Hi, everybody. I'm Judy. Yeah, I think it's been about 5 years. I've been a Tidepool docent. And, you know, when I first took this class, I wasn't planning on being a docent, and I just wanted to learn about the tide pools. And I think it was Hollis who said, "No, it's really fun." And so I tried it, and it is really fun to be with the kids. So, and I'm surprised because, yeah, I'm not a teacher. I don't hang out with a lot of kids, and I felt like I probably wouldn't be the right person, but it really doesn't matter if you have enthusiasm for the tide pools, because the kids certainly do. And also following Hollis is difficult because she knows so much about all the animals, and and the environment itself. So when I took the class, I felt a little intimidated by the fact that I knew nothing. I knew I'd seen barnacles and I knew a sea anemone when I saw one, but I didn't know anything about them really. In fact, I didn't really think about it, but I didn't know that barnacles were animals. They were just like, I don't know, something on the rock. So it's been really fun to learn, and you can learn at your own pace. The kids are excited to see almost anything, like the hermit crabs. I mean, there's just, screams of joy when they find the hermit crabs. So um, it's it's simple that way. Being a docent, we don't have to be at Hollis's level of knowledge. It certainly helps because her stories are great, but I'm never going to make it there. So I do enjoy it.
We all learn from each other, Judy.
That's true. That's very true. So you can turn the slide. So here we are out there. This was one of the days that we went out, and you can see it gets a little crowded out there. Hollis was talking about being careful on the rocks. Sometimes it's really hard. They're very covered, but if a lot of the classes are very good at that, and the docents are too. It's hard for us. I'm 70 and walking over these rocks, I'm often sore the next day, but it's so much fun. Okay. Next slide. Here we are again. You can see the environment here. I was kind of surprised when I first saw it because it's a rocky intertidal, and I was thinking tide pools are, little pools. And so I grew up in near Santa Barbara, and we just didn't have this kind of coastline there. And then here I am with another docent, and we're just happy. This is at the very end. We're saying goodbye to all the kids. Okay, next slide. So this is actually at Pinnacles, which we don't do with the kids, but it is a great beach for the intertidal to see a lot of animals. And here, this is just a favorite because you can see the baby sea star down there in the water. And I was one time lucky enough to see what I called a nursery. There were about 5 or 6 baby sea stars all in the same little pool. And so there's just so much to kind of have awe and wonder about out there. And you can see how crowded it is too. I mean, they take up all the rocks. It's hard to see any space that's not covered with these animals. Okay. So there's a marine biologist who's now deceased, but his name was Wallace Nichols, and he talked about this thing called blue mind. And I have a women's group that I was doing a presentation for. We were talking about what helps us thrive. And tide poolings is one of the things that I just get so much joy out of. And so I was doing some research on what is that? I go to the ocean and I feel so good. You go to a lake, you feel really good. And so he developed this. He did a lot of research himself and worked with neurologists and others, and he came up with this concept of the blue mind. And it's that people are so deeply tied to the water and they feel something. A lot of people feel fear. Other people feel excitement. And in doing the neurology work that he did, he found that viewing nature environments trigger areas of the brain, that are rich in opioids receptors, and that actually the water scenes had the biggest effect on people. It really lit up their brains. Okay, next. So I have one more slide about this. And he also hypothesizes that one of the reasons that we're so tied to water is is the water itself, which is like our babies are 78% water at birth, and we retain a lot of that. And our brains are 80% water. I guess that's why they tell us to drink a lot. And that ocean plankton provides more than half of the planet's oxygen. So the quote I have at the top here, how inappropriate to call this planet Earth when it is quite clearly ocean. So the water covers 70% of the Earth's surface. And so it's very fascinating that most of the ocean has never been explored. And I found this out just being a Tidepool docent, how interesting it is that with the sea star wasting syndrome, it took 10 years to figure out what the bacteria was, what caused the disease. And that's a lot because we just don't study the ocean much. That's not where we put our money. So I'm just kind of fascinated because there's a lot, if you pay attention, which I do now, I read a lot, partially because of this group. We have an email group where we share a lot of information. You can see that, we're learning more and more all the time. So it's pretty fun. Next. So I didn't have any books before on tide pooling, so I just took them all off the shelf and put them in a pile here for you to see that, if you get hooked, you get hooked.
Yeah, you do.
Yeah, yeah. Okay. So Hollis talked a lot about the sea stars. I have a couple of animals that I'm going to talk about some of the weird and wonderful things because I really pretty much every time I go out, I learn something new. And so Hollis talked about the sea stars being a keystone species, which, means they really, really regulate the environment, and what happens to them matters. And she talked about the blob that came through. So I ended up going up this fall to a festival that they had up in Mendocino County about the kelp, because I had learned about the sea stars, and when they died off, that the urchins multiplied big time, and that they ate all of the kelp. And so, right before my eyes, in my time, I'm seeing these major changes to the environment, and also seeing comeback, where all of these things are starting to come back, often because we're helping, but that's fascinating too. Okay, next. It's not moving. Oh, there we go.
I think I'm ahead of you because I've noticed a lag time here.
Oh, okay. So one of the books that I showed you from my library was this one. I don't know if you can see it. Oh, because of my background, maybe it's a problem.
Is that the Drew Harvell?
Yeah, it's by Drew Harvell. It's called The Ocean's Menagerie, and she talks a lot in this book about how one of the reasons that money's now being put into studying the sea animals is can they help us with health issues, like cancer, and so with the sea star, they have great regenerative powers. You probably heard if they drop an arm, they can grow it back. And they can also grow a whole new body from an arm. So these are pretty fascinating things. And, we would love to be able to grow a new liver or heart. So they're being studied for that. And the other thing for their skin, Hollis talked about, they have the water system where they take in the water and it goes out through their system and they can walk and move that way, but they also, and that they can pry open a muscle because they aren't using muscle energy themselves. They're using this hydraulics. And they're also being studied for their skin because their skin can go, you can see how in this picture it's kind of soft looking and smooth. So they can relax it, and it does different things, and then they can get it back into that prickly state, and their body can do other things. And so they're studying this to find out whether or not they can kind of make smart skin for us, for transplants and things. Okay, next. So in this picture, again, Hollis talked about the sea anemones, and you'll see a lot of them out there. I had only ever recognized the giant green sea anemones before as sea anemones because I had no idea that the aggregating anemones that you see on the rocks here were animals at all because they kind of look like mud. And so they're all anemones and they're all a little different, and they're quite beautiful when they open up. I think that's all on that one.
There it is.
Yeah. So
The missile silos.
yeah. So this is I'll put a link in to the video. So this is a battle that Hollis mentioned about the sea anemones battling to see if they can get more territory and move over past that pathway that they have. It's a great, fun video. I show it to all my friends. They have to put up with me.
You have to see this.
Yeah. Next. I was going to play them, but we don't really have time. So with barnacles, like I said, I honestly didn't know they were animals. I don't think I really thought about what they were. Maybe I thought they were plants. I don't know. But they they were just there. They're in the higher tide area mostly. And so you see them first before you see much of anything else. And we have this wonderful photo here where the nudibranch is on a bunch of barnacles. I think Hollis could probably tell us, some of them do eat barnacles, right?
I don't know. It's a good question.
Yeah, I'm not sure. So the barnacles are, they have these little silos they live in, and they do open up a bit when the water covers them, and they've been plastered head first to a place on a rock where they live their whole life, and they feed with their feet, come out the top, and they filter feed that way. But one of the really weird and wonderful things about them is their sex life. And I have a video about that too, I'll post. And they are androgynous, so each one is male and female. They can't impregnate themselves, but they find a neighbor, and that neighbor can be male or female, depending upon what's coming their way. So, and their penises are huge for their size. I think, was it like 6 or 7 times their size? So if you
It's the
look
largest per body of any animal.
of any animal, right? And
Yeah.
so you can see
Relative.
yeah, you can see in the video, if you watch it, really how odd this is. And so I went from thinking, well, that these weren't even animals, to the fact that they're very weird animals, and wonderful. And actually, that's not only barnacles. Pretty much all of the animals have some one or two characteristics that are just very surprising.
Judy, one time a group of kindergartners came out, and to us, sometimes barnacles just look like weeds out there. And they hit the beach and they were yelling, "Real life barnacles." And it was like all of a sudden, oh my God, you're right.
Yeah, yeah.
The things we overlook.
I know, you get very used to things.
Real life barnacles.
And I think this picture of the nudibranch on the barnacles is an example of um, the sharing that we do, because I can't figure out which docent took that picture. I thought I knew, and so I asked one, and she said, no, I think it was so and so, and I asked her, and I said, well, I wonder if I took it, but I'm not really sure who took it, but we do this. We have, as a group, we have emails, and Hollis will send something out, Karen will send something out, Amber will, I will. And we say, some of us who know less put out the email that says, I found this, what is it? And then there's a great discussion about it. And we get proud of our photos that we take, and we post those, and people go, wow, that's really cool. And so somebody posted this, and I wish I knew. And honestly, I said to them, well, maybe I did, because, you take a lot of pictures when you're out there. Okay. Next. So the nudibranchs, and Hollis actually already talked about this, but it's pretty fascinating that they steal the spears from the anemones, and they are able to have them travel through their body and make it to the top there. And so this is another thing that's being studied by scientists, because we have problems with transplanting. If we transplant organs, humans have an immune system that wants to kill off that stuff. But the nudibranchs are able to take in these foreign, deadly foreign objects and transport them through their body. I think they do have a mucus that they come in, but still they're able to do that. And so again, the book, The Ocean's Menagerie by Drew Harville, I found really fascinating, because she talked about that, and really how useful it would be for scientists to have a much better understanding of that for human organ transplants. Okay, next. I guess one thing I could say is that I didn't have any science background really, and so I'd heard the terms invertebrates and vertebrates, and so many of the animals out there are invertebrates. The fish have vertebrae, but not most of these things. And it's just such a different kind of animal when they have a body system that is so different than ours. And that is a part of the studying, is that can vertebrate animals like us even can these characteristics translate over to uses for us, because they're so different. So here's just some fun pictures. This is a sea anemone eating a sea star. Kind of messy. One of the funny things about sea anemones too is they do have that one hole that things come and go from, and so you'll see a sea anemone that's closed down like these other ones here, but you'll see a shell or something sticking out, and it's like getting rid of what it couldn't digest. The first time I saw that, I was just fascinated. And when I take friends and family out, I usually try and find one and show it to them because they're pretty fascinated too. So again, that's a picture of pinnacles. You can see just how wonderful and abundant life is in some of these places. It's just a big mess. And then Bodega Head. So I think that's it. Maybe I just have my final Judy's Happy Place. So I hope what I've been able to...
You're talking about the on one hole. There's a little anemone that sometimes you'll see that's only about this big. And it's called anemone. And babies actually come out of that little disc and then land on the base in a ring around the tentacles. And they're practicing parenthood. You know, the adult anemone is taking care of those babies until they're big enough to walk off on their own. They don't disperse very far. But so that hole is used for eating, getting rid of the shell poop, and giving birth.
That's amazing.
Well, thank you, Judy. I hope you got an idea of this is somebody that walked into this program without knowing what to expect and very quickly got hooked. And I really like the slide where you meet other people and you make new friends. And our group of Tidepool docents is really its own little community, which is really quite nice.
Yeah.
So next steps. Lisa, do you want to talk about where we go from here? Is she still with us?
Yeah, can you hear me?
Yeah.
Yeah. I'm happy to talk about all that. Let me get my view back.
While she's getting set up, I just wanted to note that I did drop a couple of links in the chat responding to some questions that had been asked, including links to the Marine Detective's discussion of why it's called Aristotle's Lantern, and a link to Department of Ecology of Washington State talking about the fact that it takes a moon snail about a year to reach full size, and it can take it about 4 days to drill that hole into the clam that it's trying to eat, and a few other things in there.
Oh, thank you, Karen. So just a year to reach that size.
Yeah, that's what it says.
I thought it was longer than that.
Yeah,
it's so large.
yeah. Well, I put the links in there so you can, follow it up and see if
great.
there's any.
Thank you. How it does that in 1 year is just incredible.
Yeah, and I also I know that after they, the little embryos come out of the moon snail, out of the shell, they're wandering around, they settle on the ocean floor. So I mean, the way it's worded, it sounds like it's from start to finish, but it could also potentially be from the time they come back up. Who knows? But that's what it says. I'll let you follow the link and explore it in more depth yourself.
Oh, thank you.
This is an example of what we do. Karen looks it up and finds it and tells us.
We're all such some question comes up that nobody knows, and we're like, oh, what? I wonder what that is. And we're like, sure. Oh, and I also noted in there, put a link to, there's this really, really cool little nudibranch called, it's a type of dorad called a barnacle-eating dorad. They're these teeny little brown spotty things, and sometimes you'll find them on the barnacles, and they're called barnacle-eating dorads because they actually eat.
That's what
the barnacles, they hang out there waiting for the barnacle to open up, and then, bizarre that something would think of that as food, but hey.
As I was saying, there are things that are being discovered, all the time. And as one of us runs across, we're on different mailing lists. And as one of us runs across something, we send it out and shoot a link out to the rest of the group. And then we all kind of glomp on to, some fascinating piece of information about something that one of these animals is doing that, you would just never dream of.
One
That's
thing
part
I
of the
just want
fun.
to add there, because I think it really ties into something that Hollis and Judy both mentioned, is like all these weird things that these animals do and where we find them in the different zones and everything. And you saw Hollis mentioned a particular type of nudibranch that eats a particular type of cnidarian. So sometimes when we're out there, we'll see little eggs, like either like egg cases or other eggs. And these guys are so smart. You will see them lay their eggs right next to the food source so that when those babies emerge, they've got food right there. It's kind of creepy, to be honest, but
And the egg ribbons are really beautiful. They look like they're crocheted, some of them. They're really stunning. So here we go.
Yeah. I just wanted to mention too, I did post the links to the videos. So
I saw that. Please watch the video of Love on the Rocks. How a barnacle finds love on the rocks. When you're stuck, you're glued there. You have to come up with something creative. Sorry, Lisa.
Oh, don't be sorry at all. That this is everyone's getting a really good feel for just the community of it, like you all were saying, and the love of learning.
Oh, I got the wrong thing. Okay, go ahead.
Okay. Well, I dropped into the chat a few different links to different pages, and I'll just briefly say that if you're interested in becoming a volunteer, um, there's a process that we go through. It involves a little bit of paperwork and a few different steps. And Elise, who you met earlier, and I are here to help, as well as our volunteer coordinator, Bet Merritt, who some of you I know have already heard from because she might have reached out to you about getting your application started. I won't go into a lot of detail right now, but I will say that if this appeals to you and you're interested in getting onboarded, I am going to send a follow-up message to this that will talk about the different steps that you'll go through, or Elise, and you can write to us if you're interested as well. And then Elise will help walk you through the process of becoming a volunteer and all the things that you need to do. One thing I'll mention is that anyone who works with school groups or money in any of our visitor centers has to get fingerprinted, has to go through a live scan process. So that's just one other piece of the process if you're going to work with groups. So I just want to let you know that up front. The state parks does reimburse you for it, but it's about $50 you have to pay out first and then get reimbursed for. So I just want you to tell you that up front so you don't get through paperwork and then say, oh, I have to do that too. It is a process, and most people find it worth it. So I just we're here to help you through that. And when I was talking about stewards at the beginning, and I was saying that we do this program at Sonoma Coast, this isn't the only program we do. So if you're thinking, oh, I'd love to be out in the tide pools and, I have extra time, or I'm interested in maybe another opportunity, I also put a link in the chat to our just general volunteer opportunities page, because our cooperating agreement goes out at the Sonoma Coast and in Armstrong Redwoods and in Austin Creek State Recreation Area. And we have a great number of programs. We have 5 coastal programs. Hollis is actually the coordinator for our seabird monitoring program, which is going to have a training in a couple weeks. And we have other programs like Seal Watch and Whale Watch out at the coast as well. So we have a lot to choose from. And then we have visitor centers if you like being inside and working with people, and trail crew, and Armstrong docenting. So there's a lot of things to choose from, but you're here for tide pooling. We hope that you would love to become a tide pool docent with us as well. So I would love to actually see if anyone has any questions at all. Oh, and I also want to say, as a volunteer, you get the community of being part of this group of Tidepool docents or whatever program you're in. And we also do a couple of volunteer celebrations and other events throughout the years to so people can get to know people in other programs. I'm curious if anyone has any questions. Oh, okay, Hollis, you can take that one or someone can. Best footwear for tide pooling.
Okay. A lot of people like to wear knee-high boots, because you're kind of clomping around in deep water. I've always preferred old trail shoes. They're worn out trail shoes. They no longer have their Scotch guard. They're no longer waterproof, but it's kind of like wearing a wetsuit. Once your feet get wet, they stay warm. But the reason I like them is for the grip, because it is slippery out there, and old trail shoes tend to have good tread, and the rocks are slippery, the algae is slippery. You do not want to take a fall out there. And then again, I want to reiterate the value of having a nice walking stick for that 3-point stance, which is really excellent for your balance. So either like muck, waterproof boots, or anything that has a good tread so that you're not as likely to slip out there. These rocks are sharp. One thing I want to stress is that we do get awfully nerdy, and I don't want that to be intimidating to anybody. When we take the students out there, there are two primary things that we're interested in. Number one is that we want to make sure that they know how to explore these areas with their own safety in mind. It is the ocean. You do have to be mindful of waves that are coming in farther than expected at times. So somebody has to be keeping an eye out on things. And I want the kids to learn to not turn their backs on the ocean, and, to look out for themselves and for each other. But the other thing is to learn to have respect for the inhabitants of these ecosystems, because it's a very, very challenging place for them to be living in. They go through extremes of temperature. There's wet and dry, hot and cold. As I said, they're exposed to predation during low tide, and so it's a delicate situation for them. And so we want to make sure that people learn to explore these areas, respecting the inhabitants. There's a fellow, I don't know if some of you are aware of Richard Charter, who is an honest to God ocean champion. He's one of the primary reasons that we have a marine sanctuary system, a national marine sanctuary system, and we don't have oil derricks off of our coast here. And Richard grew up somewhere outside, I think it was near Mount Diablo, and his father would come to the northern Sonoma coast to go ab diving. And Richard wasn't big enough to go ab diving, so Richard played in the tide pools. And he told me that that's where he learned his love of the ocean. So when you're bringing these children out and you're exposing them to this kind of environment, you don't know what kind of effect you're having on them and what kind of effect this environment is having on them. And as Judy said, we know very little about the ocean relative to what we know about terrestrial animals. There's a lot to learn. There are a lot of changes that we're watching with our own eyes out there. And if these kids aren't exposed to it, they're not going to grow up caring about it. So I feel that it's important that they get exposure to this kind of environment and learn to love it just as we do. You just don't know what kind of impact you're having.
So there's a couple more questions, Hollis, that I see here.
Someone was asking about Pinnacle Gulch. And the reason that we don't go to Pinnacle Gulch is that this is a state parks volunteer program, and that's part of regional parks. And they do a Tidepool education program in regional parks, but we're in the Sonoma Coast State Park. It's a wonderful place, though.
I'm having trouble seeing. Oh, now I've got the chat. Okay, I'm sorry. I was not being able to get it up here. I have a different interface. It's a different version of Zoom, and I'm completely lost here.
So somebody wanted to know about more about the stars, the wasting disease, and the fact that you talked about that, these are changed. These aren't the same genetic.
Oh, the mutant.
Yeah.
The Pisaster, the ochre star, which is the most commonly seen star out here, they've actually been the most successful at coming back. And they were originally hit with a red tide. It was a very unusual red tide. It was a neurotoxin that occurred in 2011. And it was species specific. We used to have big gumboot chitons. They're the largest chitons in the world. They're kind of the size of footballs. And they were all over our beaches, and they were decimated by this red tide. It was localized between Bodega Bay and I don't know if it went all the way up to Mendocino County. I know that it went up into northern Sonoma County because it was hitting the abalone areas up there. But a friend of mine called me one time. He had walked down Shell Beach, and it was littered with dead ochre sea stars. And he didn't know if somebody had been collecting them and then just tossing them up onto the beach to dry out, or what had happened. But what had happened was it was this red tide. It was this neurotoxin. And so it knocked out the gumboot chitons, which have come back. They haven't been affected in other places, but they're still rare along our coast where they used to be quite common. So this knocked out the ochre sea stars the first time, and they recovered, and they were just starting to come back, and then the sea star wasting syndrome hit, and so they were knocked out. This was a 1-2 punch, and they seem to be really resilient compared to some of the other species. There is I was talking about the parenthood practiced by the little tiny proliferating anemone. There's also a little tiny 6-rayed star that was, again, this is a local, been a local impact. It's not true in other parts of California so much as it is along our coast. And in the springtime, it had 6 little arms. It was a little tiny thing, and it would cradle its babies, its eggs, and then its babies. And it has not made the same kind of comeback as the ochre sea star. The thing about the big sunflower star, it's an apex predator. And, when we would find them on our field trips, we would release one into a tide pool, and the tide pool would look like it was perfectly still, like there was nothing going on in there. But you would release this big apex predator into the pool, and all of a sudden you're aware of everything scurrying around the edges of the pool and burying themselves. And this is it's like letting loose a lion on the Serengeti or something. This is a serious predator. And it was impacted by the wasting disease to the extent to where it was the phrase that really concerned me is scientists are very careful with their qualifiers, but to hear the term functionally extinct is really quite alarming. There's a lab up in Washington, there's a lab in Half Moon Bay. The Bodega Marine Lab is doing some work on them now, where they're raising them in the laboratories to release them into the wild, hoping to repopulate these areas so that we could get back our giant kelp forests. And so I was talking about the impact of a keystone species when I was talking about our ochre stars and the impact that it had on the life on the rocks that we were seeing. You lose a predator like the sunflower sea star, and you have an entire ecosystem virtually collapsing. And so we're hoping for a successful restoration. And Judy was talking about the kelp festival up in Mendocino, and this is the focus of these festivals now, is to educate people about the importance of this ecosystem and the efforts that people are making for restoration. So there were a total, this is the largest marine mortality event that has been recorded in history. And it's kind of stunning to have it happen before your very eyes. The other thing that we saw during the heat wave, though, that was kind of interesting is we saw the migration of southern species that we don't normally see in our tide pools. There's a beautiful nudibranch. It's a Rosie Hopkins. It is a hot pink color. And they're common in Southern California up to about Monterey. And we were suddenly seeing explosions of those in our tide pools. The cool water returned and they disappeared. So we were also, and of course, when you have species coming in from Southern California and from other areas, that disturbs the whole balance within a tide pool. There's one nudibranch that moved onto Duxbury Reef and ate the predominant nudibranch there. And then it eventually kind of ate itself out of prey and a balance was restored. But when you have animals coming in from the outside, it's almost like an invasive species. It upsets a balance that's already very, very delicate. So these are some of the things that we've actually been observing over the last 10 or 15 years, right off of our coast. Are there any other questions?
I had a question about the docent part of the program. Is this program all for school children, and do you have to be available Monday through Friday, or do you do anything for other visitors that might not be Monday through Friday?
Oh, okay. So we've had roving docents that patrol beaches on weekends, basically on weekends, and they accompany park visitors. And again, the objective is to show park visitors how a lot of our visitors are from out of state. This is the first ocean experience for some of these adults, and they are often not aware of the dangers of the ocean. And so it's to show them, it's to model behaviors so that they're taking care of themselves, and then also to expose them to these environments. But the requirements for that program are in flux right now. And so that's why I'm hesitant to discuss that, but we will be bringing it up. And that's basically our heaviest visitation is on the weekends. So that's ideal for somebody who's working Monday through Friday. This is my 19th year with the program, and I was working full time, but I found that I was having trouble taking my PTO. And this was an excuse. And so that in the spring, we would get the tide pool schedule and I would turn in the schedule to my boss because the two of us couldn't be off campus at the same time. And she used to grin and she'd say, "You're the only person I know who plans her life around the phases of the moon." But so even for those of us that are working Monday through Friday, sometimes it's a good excuse. It's an opportunity to get away.
If
Karen?
I could I'll jump in a little bit. Yeah, as
Yeah.
Hollis said, there are some changes going on with that. So I know right now they're not like adding any new like roving docents for all that thing. But in addition to just like the roving, in the past we have conducted tide pool events for the general public, particularly around the king tides. We'll go out in the morning and look at how enormous the tides are, and then we'll come back in the afternoon and do a docent guided tide pooling. Again, that wouldn't be at this time of year until possibly in midsummer, and then again in like December. And I mean, it will really be up to state parks and stewards whether new protocols are in place for that to allow the docents to lead those again. But
we did have one of those events scheduled a couple of weeks ago, but the weather didn't cooperate.
Yeah, and we will sometimes, get requests from people. Like I remember a few years ago, we had a intertribal group come out, and they brought families, and we have lots of, public groups requesting, and it's just like, I think they're just like Hollis said, still figuring out the logistics of whether any of that's going to change in terms of like what duty statements you have to sign and all that. So Lisa and Elise will get all that to us when that all happens.
Thank you.
Hollis, do you want to talk about the
question? Oh,
do you want to talk, Hollis, about the main part, like the months of the really peak tide pooling time?
Yeah, I kind of rushed through a lot of this because I wasn't sure about our time constraints. Um, our school classroom trips, actually, they start next week. And they're scheduled generally March into the first week of June. And this is because the low tides are in the spring months are during the morning hours when it is, convenient for them to come out. Um, it'd be wonderful to be able to schedule things in the fall, but the low tides are in the late afternoon during the fall months. And so everything is kind of concentrated basically in April and May. One of the other things that we do before a field trip is that somebody will go out and scout the beach. The beaches suffer heavy erosion with the winter storms. There's a lot of sand that's sucked out. And so in areas that like in the month of May, might be sandy and easy walking. Right now, it could be boulders if that much sand has washed out and it has not replenished itself again. So one of the things that we do is that a week before we have a lot of field trips scheduled is that somebody will go out and scout the beach, make sure that everything is accessible and make sure that it's safe. If not, we do have other options available to us. We do have other beaches that we can go to. I think we have the 25, 27 field trips scheduled, starting next week, actually, running through the first week of June. So our schedule is jam-packed. It's a very popular program with the schools, and especially Lisa has been managing this grant, which is just incredible. It's just wonderful because it enables Title I schools who otherwise could not afford the transportation costs to bring their classes out. And Lisa, I know that you visited Flowery a couple of weeks ago, and what was it that the teacher said about when the kids came in on the bus?
Flowery School is in Sonoma, and a lot of the students they were in first grade, they had never seen the ocean before. And the teachers who were on the bus said they came around the corner and they came to the coast, and the kids started to just yell and cheer about about getting to see the ocean for the first time, and it just brought tears to the teachers' eyes. And it's really something. And actually, this whole program is free of charge to schools. It's just that some of these schools will pay through this grant process that we're part of, the Pathways Project. Will pay 100% of the transportation costs, which can be, often between $300 and up to $700 just to for one bus ride. I would also like to, I know we might have some other questions, but I did want to mention the in-person training that's coming up next weekend on the March 1st. And maybe some of you are planning on coming to that, and we'll put more information in the follow-up email. But does anyone, Hollis, everyone, you want to talk a little bit about some of the, okay, Karen has put some details here, great, in the chat. So the training is actually on the schedule for 3 to 5 p.m. But you can certainly come early. We'll really start at 3.
It's a little unclear because on the actual spreadsheet it says 2:30 to 4:30, but on somewhere else it says 3 to 5, and the actual low hits at about 3:40. So
yeah, when we set it up as a training, it was set up for 3 to 5. So that was the word that went out. And it's fine to show up a little early and people can talk and learn a lot. It'll be great. But definitely, who wants to, let's talk about what to wear. Be prepared with lots of good layers of clothing, warm layers. Could be actually kind of beautiful weather, I think, this weekend. But definitely shoes that can get wet, the footwear we talked about, drinking water, snack, if you have a special like hand lens that you like to use, your camera. What else?
I noticed that Lori mentioned here another phenomena is the velellas. And this is another animal. Actually, it looks like a singular animal, but it's really a colony. And sometimes in the spring, it's bright blue, it's dark blue, and it has kind of a disc, and it has tentacles that hang down below, and it has a sail, and the sail is it is kind of slanted on the body, and so it sails along the surface of the ocean. Masses of them do. And if the wind changes, if the wind starts coming from the south instead of the north, it catches that sail and they'll wash in to the beach. And so suddenly we'll have masses of them. Last spring, it was just incredible. There were thousands of them washing in all over the place. And they're called Velella. And they're really charming. They look like little sailboats, and they're charming little animals. So thank you for mentioning those in the chat, Lori. I'm just now getting the chat up. I have a different version of Zoom, and I'm getting used to the interface here. I'm sorry about this. And the kids really love the name Velella, and especially if you tell them that what eats them are the mola, which of course are the big sunfish. And I'm looking for other questions here. By the wind sailors is the other name for them. What should we know about Sunday's expedition? What is the tide elevation? In order to go to Campbell Cove, you need one of the handouts in the handout folder is a list of Sonoma Coast beaches and the kind of low tide that you need for each beach. And I mentioned we like to use Miwok for our field trips because we've got good exposure of life on the rocks up to almost 2 feet. A 1.7 plus is really quite good. Campbell Cove, you need a minus 0.5 in order to get all the way out to the jetty. There's a rock jetty out there, which has a lot of the same animals that you'll find on the rocks on the outer coast. But then you also have the animals like the clams and the cockles and the moon snails and animals that can live in a calmer environment. And so I'm not quite sure of what the exact tide is. I can look it up off of the schedule, but it'll be greater than a minus.
Chat there, Hollis. It's in the chat.
It'll be greater than a minus 0.5. We need that.
Negative 0.7 at 340.
Yeah. And that's the other thing to be aware of. Just because you have a good low tide at one beach, it doesn't necessarily mean that another beach along the coast, along the same coast, is safe there. The Sonoma Coast is just a whole series of little pocket beaches, each with their own characteristics and each with their own population of animals as well. So I'm looking for other questions. Does anybody have anything else? Well, thank you so much for coming. And I hope you're interested in joining us.